You see a headline about a wild new study, or a post goes viral with some shocking new finding. How in the world do you know what to actually believe? Well, today we're building a toolkit. It's what one writer called a personal crap detection system. We're going to dive into how researchers figure out if a study's claims are the real deal. Okay, let's get into it.
We all walk around with these gut feelings, right? Little bits of common sense that tell us how the world works. But here's the thing. What happens when we actually put that common sense to the test? Well, the results can be, and often are, the exact opposite of what you'd expect. Okay, how about this one? For years, the story has been a definite yes. We've all heard it. Parents, teachers, you name it, worrying that using text speak, great for great, or you are for your, is basically rotting kids' brains and their ability to write properly. It seems obvious, doesn't it? Well, get this. When researchers actually put it under the microscope, they found the complete opposite. The kids who were fluent in these textisms were actually better at verbal reasoning. They even had better spelling skills. And this is a perfect example of why we can't just go with our gut. We need a real system to check the evidence.
And that's where this idea of a crap detection system comes roaring back. The phrase comes from Neil Postman, and it's all about one thing: getting better at spotting the flaws in arguments, especially when they throw numbers and findings at you to sound convincing. To do that, you need the right tools.
So, what is this magic tool? Well, for researchers, there's one core concept they use to pressure test everything. It's their ultimate reality check, and it's called validity. In plain English, validity just asks one simple question. Is this for real? Did we really discover what we think we discovered? Or could something else, some kind of contaminating variable, be messing with our results and creating a false impression? It's all about how much we can trust the conclusions we draw. Now, it's super easy to get validity mixed up with its cousin, reliability. But this little analogy nails the difference. Think about it. Reliability is just about being consistent. So a speedometer that's always 10 miles per hour too fast is totally reliable. It consistently gives you the same wrong answer. But it's not valid because it isn't measuring your actual speed. Validity is about being accurate. So a valid speedometer is both reliable and it measures what it's supposed to. And that's the key takeaway. You can have reliability without validity, but you really can't have validity without also being reliable. All right, so to really understand if a study is solid, you've got to pop the hood and see how it was put together. This takes us to the specific types of validity that researchers use to inspect the internal guts of their own experiments. So, they're basically asking three huge questions. First, is this result we're seeing just a random statistical fluke? That's what we call statistical conclusion validity. Second, did the thing we did in the experiment actually cause the result we saw? That's internal validity. And third, are we actually measuring the big idea, the construct that we think we're measuring? And that, my friends, is construct validity. Okay, so the difference between internal and construct validity can feel a little tricky, but this chart lays it out perfectly. If you have no internal validity, it means the whole experiment might be a bust. The effect might have happened no matter what. Maybe one group of people was just better at the task from the get-go. But a construct validity problem is different. In that case, the experiment did cause an effect, for sure, but it wasn't for the reason the researcher thinks. Something else, a confounding variable, was secretly pulling the strings. And here is one of the all-time great examples of confounding. Back in the 70s, Pepsi ran this huge ad campaign showing that in blind taste tests, people chose Pepsi, which was in a cup with an M on it, over Coke, which was in a cup with a Q. Seemed like a slam dunk for Pepsi, right? Well, Coke fought back with their own research, and it turned out people just have a weird subconscious preference for the letter M over the letter Q. Seriously. The letter preference was the confounding variable, not the taste of the soda. The test created an effect, but it was measuring the wrong thing entirely. Okay, so let's imagine a study is built like a tank on the inside. All its internal checks are solid. That's great. But the next, and maybe even bigger question is, do these findings actually mean anything outside the sterile, controlled world of the lab? This is what we call external validity. And you could think of it as the bridge connecting the research to the real world. It's asking, hey, do the results we got from a small group of college kids in one city today actually apply to, say, retired mechanics in another country 10 years from now? Can we generalize it? Now, whenever people start talking about research and the real world, there's a phrase that pops up all the time: ecological validity. And I've got to tell you, it's probably one of the most misused and misunderstood concepts in this entire field.
So, the popular version, what you might call the pop psychology idea, is that a study has ecological validity if the setting just feels real or natural. But that's not really the point. The real scientific question isn't, is it realistic? It's, do the findings generalize? In other words, does the effect you found hold up in other settings, whether those settings are real or totally artificial?
This comparison right here is the ultimate myth buster. On one hand, you have the Hoffley nurse study. It took place in a supernatural setting, a real hospital, but its crazy results, where nurses almost gave a patient an overdose on a fake doctor's orders, have never been successfully replicated. On the other hand, you have Milgram's famous obedience study. The setting was completely artificial, a lab, a guy in a white coat, a fake shock generator, but its core finding about obedience to authority, it has been replicated time and time again in different countries and different settings. So the bottom line is, a natural setting is no guarantee of a useful finding, and an artificial one doesn't make it useless. It's all about whether the results generalize.
So, after all of that, where does that leave us? What should you take away from all this? Well, we've just put together a really powerful 4-part toolkit for thinking critically about pretty much any research claim that comes your way. And here it is, 4 simple but incredibly powerful questions. Number 1, is the effect they found real, or could it just be a random statistical fluke? Number 2, did the experiment itself actually cause the outcome? That's your internal validity. Number 3, is their explanation for the cause the right one? That's construct validity. And finally, number 4, do these results actually apply to the rest of us in the wider world? That's external validity. And there you have it. You are now equipped with the same basic framework that scientists use to check their work. And this isn't just for academics. It's a way of thinking that helps you cut through the noise. So the next time you see that flashy headline about a new study, you'll know exactly what questions to ask. So, what finding will you put to the test? Thanks for joining me.